So next we are going to start learn about the combinational circuits. Okay. So basically we'll have two types of circuit. One is the combinational circuits and another one is the sequential circuit. Okay. In the combinational circuit, what happens, like if we'll provide some of the input, accordingly we'll get some output, right? But in sequential circuit, we'll give some input, then from that output will come, that will become the input of the next object. Okay, then we'll have output for this, again that will become the input for the next. So as its name suggests, sequential means sequence, that it's in a sequence way, right? So from here to here, here to here, it will come in a sequence. Okay, this is the first difference. Second difference is in this combinational circuit we have no memory, but in sequential circuit we'll have memory which will store the element. Okay, example of the combinational circuit which we are going to learn about it, that is adder, subtractor, multiplexer and demultiplexer. All this thing is mentioned in your syllabus, so you need to study about it. Example of the sequential circuit is flip-flop, counters and registers. Again, all this thing is also mentioned in your syllabus, so you need to study this one. Got it? Now first we'll learn about the combinational circuit. In the combinational circuit, we'll have two things. One is the adder, another one is the subtractor. Okay, adder is divided into category. One is the adder, another one is the full adder. Similarly, subtractor is also divided into two parts. One is the half subtractor and one is the full subtractor. Okay, now half adder means it will include two inputs. Two inputs means we'll have A and, got it? Now if we'll add something like 1 plus 10 is how much? 10 plus 1 is how much? 0 plus 1 is 1, right? Then 1. So we'll get sum, correct? Suppose if I'll add 19 plus 8. So 8 plus 9 is how much? 17. 17. So 1 will, that will be the carry, right? So that would be the 27. So in the output, either will get sum and will get carry, right? Like this 1 is the carry and 27 is the whole sum. Got it? Similarly, in the full adder, we'll have three inputs. A, they are the three inputs. Then and in the output, we'll have things again, sum and carry. Okay? Any doubt up to here? Tell me. Okay. So first of all, we will learn about half adder in. So in this we'll have, let's draw the truth table first. As I told you, this will have two inputs and two outputs, correct? So two inputs A, and as I told, if we'll have two inputs, then tell me how many are the possible combination? That is raised power 2, right? 4. There are, if there are three inputs, then how many are the possible combination? That is 2 raised power 3 is equal to 8, correct? So 2 raised power 2 equal to 4 means we'll have two possible combination, four possible combinations. And if we'll have four possible combination, how will we write it down? Like 4 divided by 2 is 2. So 2 times 0, 2 times 1. Okay. Then 0, 1, 0, 1. Got it? Then we'll have sum that is denoted by S. Then we'll have carry that is denoted by C. Right? So sum is how much? Like as you know, 0 plus 0 is how much? Obviously 0. 0 plus 1 is how much? 1. 1 plus 0 is how much? Tell me. 1, right? But 1 plus 1 is how much in digital terms? It will be 0. But there is a 1 carry over there. Got it? So this one is different from the maths. You have to remember this. 1 plus 1 is always 0 and 1 is the carry. So we'll do the same thing. 0 plus 0 is 0. Carry is 0. 0 plus 1 is what? 0 plus 1 is 1. Carry is 0. Right? Again 1 plus 0 is 1. Carry is 0. 1 plus 1 is 0. Carry is 1. Got it? Hmm? Now tell me if there is any doubt up to here. Now the next step, like first step, we have to draw the truth table, right? Next step, we need to calculate or derive the expression of the sum, and we need to derive the expression of the carry. Okay, so how can we get it the expression for the sum and the carry? That we have to use k map, but k map is you said कि अभी करवाया नहीं है. Okay, I'm telling you the direct expression, but that expression will get it from the K map. K map I'll teach you later on. Okay. So some expression will get it as A XOR B. Okay. And carry expression will get it as A dot B. Okay. Now the next step. Yeah. See, we got the expression for the sum that is A XOR B. Right. And for the carry we got it as A dot B. So this is XOR gate, right? XOR gate symbol is like this, correct? This is the multiplication, so it is the AND gate, correct? And AND gate symbol is like this. So you can see that we'll have two inputs. One of the input is A, another of the input is B. So A XOR B. Okay, this is the output for the sum. Then A dot B multiplication. This is the output of the carry. So this is how we will realize the expression by using logic gates. Got it? Now similarly we have to do it for the full adder, correct? So in case of full adder, as I told you, we'll have how many inputs? 3 inputs, right? And 2 are the outputs. So let's draw it. A, B, C. I told you if there are 3 possible inputs, then how many are the possible combination? That is 2 raised by 3. That is 8. 8 divided by 2 is 4. So we'll have 4 times 0, 4 times 1. Right? 2 times 0, half it. 2 times 1. 2 times 0, 2 times 1. Then 0, 1. 0 1 0 1 and 0 1. Then we'll write down the expression for sum and carry. Okay, now you know how to do the sum. Complete this table and then let me know. So after using k-map, we'll get the expression for sum as A XOR B XOR C, and for the carry we'll get the expression as A B plus AC plus BC. Okay, AB plus BC plus AC. So now what do you need to do? You have expression, realize this function, realize this expression by using logic gates. Okay, similarly what we have done for the half adder, then we'll do it for the full adder. How this expression came, it directly came it from the K-map. Once I'll tell you the K-map, then I'll repeat this part, that how we can get the expression of full adder by using K-map. Okay, we can't get direct expression. So now realize this expression by using logic gates. Do it. Expression for sum and carry is this one. Next we need to draw and realize it by using gates. So we'll have three inputs. Three inputs is A, B, C. The expression for the sum is what? The XOR gate. So we'll draw for the XOR gate like this. This is the expression for the sum. Now the expression for the carry is A and B multiplication. A and B is combined with AND gate. With the AND gate. Similarly, B and C are combined with the AND gate. Similarly, A and C are combined with the AND gate. Then it will all combine with the OR gate. It is carry. Okay, understood? Now next what they'll ask you from the adder question, that you have to draw full adder using half adder. Okay, means suppose you will have half adder in your hand. Now you need to draw, you need to get the output of the full adder. So how will you do it? You need two half adder to draw the full adder. Okay, this is half adder 1, this is half adder 2, right? In the input of the half adder, you will provide two inputs, right? One of the input is A, another of the input is B. Similarly, in the half adder 2 also will have two inputs. One of the input is A, another input is B, and will have two outputs, correct? One of the output is sum and another is carry, correct? So for similarly for the half adder 2 will have two outputs. One will have sum and one will have carry, correct? So in this will have, now see how we can connect these two. The output of the sum will become the input of the next half adder. Okay, now the output of carry of the first half adder and the output of the carry of the second half adder will be combined with the OR gate. It will give a final output carry, final carry output. Okay, this is the sum final, this is the carry final. Got it? Now if I'll combine it, it will become a full adder. But as you know, in the full adder we'll provide three inputs, but here we are providing two inputs. So next third input also we are providing C, and that C input will become the input of the second half adder. Okay, so now as you can see in this box, it consists of two half adder and it will behave as a single full adder. In this we'll have three inputs, A, B and C will have two outputs. One is sum and another is carry. Got it? So this is the like half diagram I make it. In this we don't need to show it half adder like this. As you know, half adder expression is like sum expression is A XOR B, right? And carry expression is A dot B. So in short, if I draw for the half adder, this is the box of half adder. In this we are providing the two inputs, right? One of the two of the inputs for the sum we'll draw this box, right? For the XOR gate, and then for the AND gate, this is A and B. So instead of this half adder 1 write down, first draw this diagram, then you have to redraw the diagram by putting this half adder block in that. Okay, so this is half adder 1. Similarly you need to draw it for half adder 2, then recombine it. Okay, now I'm drawing it again for you, like the OR gate, and we'll have AND gate, this half adder 1. Similarly we'll have XOR gate, and we'll have AND gate. This is half adder, right? In box half adder 1, this is in box half adder 2. Now this is carry, right? This is sum, correct? So carry output of this one and this one will be combined with the OR gate. That would be the final carry, right? Here the output of the sum will become the input of the XOR gate, right? Next we'll provide the third input, that is, this was A. This third input will become the input of the second half adder, that is this. So this is the sum. Okay, in short I replace a half adder box, this one half adder. So you have to show it by this one first, then you need to draw it for this one. If I told you directly this diagram, then you won't be able to show it, correct? Now tell me any doubt. Now for this particular case, for combining two half adder into a full adder, we have to write down in the form of expression also. Like if I'll see from here, some expression is how much? This is A XOR B, right? And if I enter here A XOR B, this one is C, right? So output is A XOR B XOR C, right? This is the exact output of the sum of the full adder. Now we'll see for the carry. The output of this one is A dot, right? And this one is, so output for this one is how much? Like this is one of the input is A XOR B. Yeah? One of the input is C, so we'll need to multiply it. AK expression, this expression will get it, and another expression will get it as A dot B, correct? Then it would be added with each other. So finally what we got it for this one of the input is this one, that is A dot B. It's an OR gate, so we'll add. Another of the input is this one, that is A XOR B dot C, right? But this carry expression doesn't match with our carry expression of full adder. Now see what we got, carry expression for the full adder AB plus AC plus BC, right? But what we got it here, A dot B plus A XOR B dot C. So this expression matches with our expression, with our final expression of full adder. No, now. So we need to solve it further for the carry. Like carry, we got it as A XOR plus AB. But what we want AB plus BC plus AC, right? So we have to solve it, and let's check whether this expression will come, then our diagram is correct. If this expression is not correct, not come, then our diagram is not correct, correct? Now A XOR B is how much? A bar B plus AB bar multiplied by C plus AB, right? Then I'm multiplying the C with every term, A bar B plus AB bar C plus AB, right? Now, can I multiply this thing by 1 plus C so that it will be added? As you know, according to the Boolean laws, 1 plus C, how much? 1 plus C is equal to 1 only. If I'll add 1 to any number, that would be equal to 1. Okay, so that would be A bar B C as it is, AB bar C as it is, AB, I'm multiplying, then AB, correct? So now we'll have B and B. Can take B common from these. Then the left term would be A bar plus A. Rest of the term is same, AB bar C plus, correct? Now A bar plus A is 1, so it would be 1 is B only. Then AB bar C plus AB. Now C we got B. That's what we want, right? Got it? Now left term is AB and AC. So what we'll do, again we'll do the same thing. AB is there, we'll add 1 plus, so do it again, AB bar C plus A plus A, sorry, plus C, AB है. यहाँ पे AB था, we'll multiply with this one C, AB, then again AB plus ABC, right? So again AC, one is AC, from this one AC. We get it common. I'm writing here only. BC will as it is, as we want BC. AB as it is, again as we want AB. Now from these terms we can take common. The left one would be B plus B bar. And as you already know, B plus B bar is equal to 1. So what we got, the final expression plus AB plus AC. Our final expression. Okay, our final expression. This is what we want, means our diagram is correct. If they'll give you the question that draw full adder using two half adder, you have to write down this expression. And as I told you, an important first 2 or 3 times it already comes in. Next, similarly we have studied for the adder. Now we'll see from the subtract. As I told you, in this we study about the half subtractor and full subtractor. So subtractor is like 2 minus 0 is 2, right? 0 minus 1 is how much? Can you subtract 0 with the minus 1? For that you need to take a borrow, right? Then only you will be able to do. So 0 minus 1 would be 1 only. So basically the difference is 1. For this case you have to take the borrow is also 1, as it's in the digital form, so you can't move other than 0 and 1, right? Then 1 minus 0 is 1, and the borrow. Now tell me 1 minus 1 is how much? Borrow is also correct. So now draw the table for half subtractor. In the half subtractor, how many inputs take it? Input A, only 2 input for the half subtractor. And for the full subtractor, how many inputs take it? That is A and, correct. Now how many are the outputs? As you know, there are two outputs. One is the difference and another one is the borrow, right? In this case also we'll have difference and, correct. So do it. So 2 times 0, 2 times 1, 0, 1, 0, 1. And for this one, 4 times 0, 4 times 1, so 1, 2 times 0 times 1, so 2 times 1, so 1, 0, 1, 0, 1, so 1. Now complete the table. So this is the table, and then we'll again get from the K map. Okay, so I'm telling you that the direct expression for this difference, it would be A exo, and for the borrow, A bar. Okay, this is for the half. Next, for the full subtraction, will have expression for the borrow as a bar b plus a bar, like in this, so it would, sorry, borrow expression is a bar b plus a bar c plus, okay. Now the difference expression is a, okay. Now again you need to draw that same thing, draw full subtractor using half subtractor. So one of the question will definitely come, either they give it from the header or they'll give it from the subtract. Okay. So for this you have to do the realize this expression by using gate. So that we have done the same thing in the case of adder. So in midterm and in end term, you will definitely get the question of either adder or either subtractor, but the important one is adder. Okay, not like that they can't give you the question of subtractor, but important one is adder. Understood?